All right, everybody, let's talk about functions. So first of all, today we talked about domain restrictions on functions. So let's talk about functions first. So here's one definition. Every element in the domain is paired to exactly one element in the range. Or we had talked about every x value can only be paired with one y value. Okay, and so we drew a couple of pictures of that. We know that example, this is yes, a function. Every point has an exactly one, and of course we know a picture like this is not. This is no, because you have an x value with two y values. Okay. Now, domain is all elements in the independent variable, but normally say it's x, but that's all the x values, and the range is all the y values, are all elements in the dependent variable. Okay. To find the vertical line test, really easy. If you draw a line straight down, if it crosses in more than one place, it's not a function because you have an x value with two different y values. It doesn't make any sense. And then we talk about zeros. Zeros are any value, any x value that makes the function equal to 0. Okay. All right. So it's also x-intercepts. So example 1, we cannot divide by 0. Cannot. If x were -4, we'd have 1 divided by -4/4, and you cannot. So x cannot equal -4. So the domain is all real numbers. It can be everything except -4. So you can plug in any number you want, but you better not put -4 in. Okay. You can even look at the graph. We looked at the graph, and it has a weird asymptote at -4. Example 2. We know you can't have negative square roots, so if x were -4, you'd have a 0, and the square root of 0 is okay, but if you have -5, not okay, so it's got to be everything greater than or equal to -4 for the graph. Okay, and if you looked at the graph of this, it looks like this at -4. If you looked at this graph, we did this on Desmos, it has a weird looking asymptote at -4, and the graph looks something like this. Okay. This one's weird because when you graph this one, you get a half circle, right? You'll graph it on Desmos. And so the domain exists between -3 and 3 because any other value will make it have a negative square root, which you can't. So that's the domain from -3 to 3. Okay. Example 4, you have to factor the denominator. Remember, you can't divide by 0, so I factor the denominator. And if x are 4, I'm in trouble because you get 4 minus 4. And if x are -2, you're in trouble, -2 plus 2, okay? So it can be everything except these two values. It cannot be 4, it cannot be -2. So the domain is all real numbers except x cannot equal 4 or -2. And 7's a little bit of a weird one because you can't divide by 0 and it can't be 1. When you look at this graph, it seems to be kind of like an asymptote at 1. And the graph looks something like this. So it just goes, and so it's all of these values, but it can't equal 1, but its x is greater than 1, okay? Now, if I take a look at the back side, we wanted to take a look at an absolute value graph. We went back to the parent function of what an absolute value graph looks like. Anything that goes in comes out positive for an absolute value graph, and that's why it's this looking V, because anything negative becomes positive. So we graphed this. We took the parent function, we moved it back 3, horizontally to the right, to the left 3, and down 4. We graph the absolute value, okay? Domain is all real numbers because it's forever y, plus you can plug anything in. And the range, though, has a height of -4 up, so greater than or equal to -4. It has zeros at 1 and at -7, so that's where my zeros are, okay? Then we did a piecewise graph in its finality. So to do a piecewise graph, I need my border points at -3, at -1, at 2, and 5. Now I got 3 pieces. First piece, if x and y are the same thing, I get a line, start at 0. Now I erased it already, but I'd start at 0 and I'd go up 1 over 1. But I don't want all of this line. Don't want all of this line, so I only want the part that's between -3 and 1. So I erased all the rest. Okay. X squared minus 1 is a parabola. And I could graph the entire parabola, but I don't want to. I only want the parabola between -1 and 2. So this part of the parabola, okay? And finally, y equals 2 is straight across at 2. It's a horizontal line, but only between 2 and 5, okay? So there's my piecewise graph. The domain, then, is from -3 to 5, not including 5. The range is from a height of -3 up to 3, but not including 3. And there is the homework, and that's all I have for you, and we'll talk about this more tomorrow.